Last one is a... All right, we're continuing our look at the binomial and geometric probabilities. We're going to look at some different AP multiple choice and free response questions. A tire manufacturer designed a new tread pattern for its all-weather tires. Repeated tests were conducted on cars of approximately the same weight traveling 60 miles per hour. The test showed that the new tread pattern enables cars to stop completely at an average distance. So your average is 125 feet with a standard deviation of 6.5 feet. And the stopping distances are approximately normally distributed. So that's a big clue that we're going to be using a z-score and normal CDF to find that probability. So what is the 70th percentile of this distribution of stopping distances? So remember that a percentile is the 70% of the values are below that. So that's an inverse norm, 0.7, which is 0.524. And then we can use that. 0.524 is our z-score, at which we have 70% of the values below that. Our x minus 125 over 6.5, our standard deviation. And we solve that by multiplying by 6.5. We get 3.408 equals x minus 125. And we're going to add 125 to both sides. And we get 128.4 is the feet, is the stopping distance for the 70th percentile. B says, what is the probability that at least two out of 5 randomly selected cars in the study will stop in a distance that is greater than the distance calculated in part A? So what is the probability that we have at least 2 of 5 stop at this distance, greater than that distance? Well, if this is a 70th percentile, then the probability that we stop in that distance is 30%. That is going to be that probability. So the probability that x is greater than or equal to 128.4 is 0.3. And then at least 2 out of 3 cars is binomial, with 5 cars and a probability of 0.3. This is how we define the model. And to find that probability, we're going to do 1 minus binom CDF 5, 0.3, 1. Because remember, if I want at least 2, that means 2 plus 3 plus 4 plus 5. And so I need to do 1 minus the probability of the 0 and 1 to get those probabilities. And that equals 0.472. So then part C actually deals with sampling distributions. So there's 3 different things in this problem. So it wants to know what is the probability that a randomly selected sample of 5 cars, and this is how you know it's a sampling distribution. Now you have 5 cars, not just a randomly selected car, have a mean stopping distance. Okay, so the sample has a mean. That's a sampling distribution where we have to use that sigma is s over the square root of n, where the standard deviation is sigma over square root n, depending on what information we have. So in this case, our z-score is going to be 130 minus 125, our mean, divided by 6.5 divided by the square root of 5. We put that in our calculator. And we get 1.72, and then we're back to normal CDF. $1.72,99. And let's see, how much is that going to delete off of that? There we go. Give us some space. So we get 0.0427. So that is answer C. So here's some multiple choice questions that I found. Only 6 out of every 100 people have blood type O positive, so the probability of O positive is 0.06. That's 6 out of 100. What's the probability that in a random sample of individuals, the first person with type O blood will be the 8th person tested? So the first person that we find with this success is the 8th person. That is geometric. Geometric with a probability of 0.06. So these three, this C88, C81, these are combinations. It's writing it a little differently than we've seen in the other problems. So those are binomial, so those are not the answer. So it's either D or E. We want one success, so it's 0.06 to the 1 power times 0.94, the probability of failure, to the 7th power, and that makes the answer D. Okay, so statistics show that 7.3% of workers between the ages of 18 and 24 earn the minimum wage or less. What is the probability that if 3 young adults between the ages of 16 and 24 are polled, 2 or more will earn the minimum wage or less? So out of 3, what's the probability that 2 or more? So I want the probability of 2 plus the probability of 3. And the probability of success in this case is equal to 0.073. So we have a binomial situation. We have success failure, we have fixed probability of success, and we have independence. So our binomial model has 3 with a probability of 0.073. And if I want the probability of 2 plus 3, I can do 1 minus the probability of 0 and 1. So that's binom CDF 3, 0.073, 1. Doing this by hand, you're doing 3, choose 2, 0.073 squared times 0.927 to the 1 plus 3, choose 3, 0.073 cubed. So that would be by hand, and this would be in the calculator. So my answer is 0.015, which is 0.0152. Here it is. Notice it has other answers that are really close, so you want to try not to round as much as possible, because it would be very easy to select B instead. Okay, suppose we have a random variable x with a probability p, and the probability of exactly 3 successes in 8 trial is given by C, the combination of 8, choose 3, p to the 3rd, 0.45. What is the mean and the standard deviation of x? So in order to do that, we need to find p. It looks like a binomial model. That's the binomial equation. So if q is 0.45, that means p is 0.55, and we have n is 8. So what's the mean and the standard deviation? So our mean for binomial model is n times p, which is 8 times 0.55. Our standard deviation is the square root of npq, which is the square root of 8 times 0.55 times 0.45. When I put those in the calculator, I get 4.4 for my mean. So that makes it either A or D. And then I get 1.407 for my standard deviation. Or sorry, A or C. So C is my answer. And that's all I have for this little segment. I hope that helps.